Good morning. Is my screen is visible to you all? Am I audible?
Yes, sir, you're audible. Your screen is not visible.
Not visible. Okay. So I think I have lost my connection. Is it visible now?
Yes, sir.
Yes, sir. Now
Okay.
it's
So
visible.
we have started the header link
Yes,
list.
sir.
So we have started the header link list. I'm just recapping it again. I think I have lost my connection because of that. Something may be missed. Okay. So header link list is a link list in which we have a special node which is known as the header node. As you are seeing in this diagram, the diagram is visible to you all.
Yes, sir.
Okay, this one is a start node. Okay, this one is the header node, and this one is the first node of the linked list. So where the header node is there in the linked list, it is in between the first node and the start node, and it is used. It can be used to hold some kind of the information related to the linked list, and that information could be the total number of nodes, maximum of the nodes, minimum of the nodes, any other link, data link. Okay, so any kind of the information can be hold. And now a linked list which contains the header node is called the header linked list. It can be of two types. First one is grounded header linked list, and second one is circular header linked list. So what is grounded header linked list? Grounded header linked list is a simple linked list with the header node. That's it. So grounded header linked list is a simple linked list with a header node. And in simply linked list, we know that the last node contains the null pointer. Okay. So what is the difference between the single linked list and the grounded linked list, grounded header linked list? We have a header node in that only. That is the difference between that. Rest all the structure is same. So start will point to header now, and header will point to the first node. In this way, the connection will be. Otherwise, in a simply linked list, start will directly point to the first node. But now, start will point to the header node, and header will point to the start node, first node. Now, circular header linked list. Circular header linked list is circular list plus header node. Okay, so it in which the last node will not contain the null pointer. It contains the null pointer of the. Tell me, in circular linked list, the last node contains the next pointer contains the address of
Start point. Oh,
Start node.
header.
Start.
start node. But in that case, it will back
Start
to
node
the header
address.
node. It will back to the header node. Now because start किसको point करता है? Header को. तो वो
Header को.
हाँ, तो last node का जो next part है, it also points to the header node actually. Is it okay? Any doubt
सर
till now?
तो फिर इसमें एक्चुअली है तो ये नोड ही है ना, तो इसको
हाँ,
सिर्फ हमने नेम चेंज कर दिया है कि इसको हेडर नोड बना दिया जो कि कंटेन कर रहा है नंबर ऑफ नोड्स और इंफॉर्मेशन.
हाँ, मतलब it will not contain the information of the linked list. Like suppose linked list में हमारे पास 5 elements contain करने हैं, then there will be 6 nodes. 5 elements will start from that, first, 2, 3, 4, and so on. Okay, that node will not be the part of the linked list, actual linked list. Okay, so linked list starts from there only. Is it clear now? Anybody wants to ask anything?
यस सर क्लियर.
What is the difference between grounded and circular now? Can anybody else tell me? कोई और हमें बताए. What is the difference between grounded header and the circular header?
सर इसका जो लास्ट नोड है
कोई और बताए हमें.
ग्राउंड.
Grounded header is actually the single linked list plus
Header node.
plus header node. Okay, and simple circular header linked list is circular linked list plus
Header
Header
node.
node.
header node. That is all.
हेडर नोड.
इससे आप ध्यान रख सकते हो आप. Is it okay? But one thing you need to remember that header node, last node will point to the header in that case. Instead of start, it will point to the header. as start is automatically pointing to the header, so बात वही है. Now header linked list can contain the special node at the top. Like you have seen that we have also seen it will be the first node always on the linked list, top of the linked list. It need not to present the same type of the data that succeeding nodes do. So you can also note that it is not necessarily that it will always hold the type of the data will be same. ऐसा जरूरी नहीं है. Okay, and it could be or it could not be. It can be able to hold the data link, number of nodes, and any other information of the linked list. Header node can access the data of all the nodes in the linked list. Okay. Now, grounded header linked list, in detail we can see a grounded header linked list is a header linked list where the last node contains the null pointer. You can see the diagram also in that case. Start will point to the header and then header will point to the first and so on. The term actually grounded kahan se aayi? That comes from the fact that many texts uses the electrical ground symbol to indicate the null pointer. It is not like so ki this is related to the CS branch actually. So the term has been used from the electrical branch. Grounded हम जानते हैं ground करना मतलब क्या होता है. Okay, circuits में हमें ground देना पड़ता है. That is what they are asking about. So now circular header linked list is another kind of a linked list. A circular header linked list is a header linked list where the last one nodes points back to the header node, and start always points to the header node in that case also. So the structure could be like this: कि start will यदि हमारे पास link empty है तो क्या हुआ? Start ये हम already पढ़ चुके हैं actually. Start का जो next है link part है वो क्या होगा? Null.
null.
And start का link part start होगा इसका मतलब क्या होगा? Circular header linked list है वो. Is it okay? Because this header node is also, this is actually start only. So start or header are same. Okay? Need not to be confused in that case. Any question? No question. Okay. So we are moving on to the benefits of the using of, first of all, circular header linked list. Instead of having that particular simply grounded, we can say grounded header linked list. The null pointer is not used. First of all, the same advantage. Null pointer will not be used. It means at the end, as in the case of simply linked list, we have a null pointer. It is used, but it is declared, but it is not being used. Okay, and hence the pointer contains some valid address. So, uska utilization ho gaya. Every node has a predecessor. So the first node may not require the special case. Same advantages we have in that case of the circular header linked list over the simply header linked list. So this is what the but now suppose you want to write the program. So what changes you will do in this? Suppose simply linked list header linked list बनानी है तो क्या changes करेंगे आप?
Start will point to header.
We need a extra node.
Header will be a node.
Header node को include करेंगे.
But the program display will start from the first node. Okay, so that you need to take care about that. It will not start with the start. Now,
So header will contain the address of first node.
Definitely, header will contain the address of first node.
So we will print with the headers next.
Yes, address next. Yes, header next. You can use the next of header. Okay, like suppose PTR you are going to declare, so PTR can be equals to next of header. Your printing will start from the node number 1, so it will start from PTR needs to be initiated with the next of header. It will not now start actually. Okay, so like suppose you are declaring a PTR with equals to start, then you need to start the loop from PTR next, not from PTR. That is you need to take care about. Okay, so we can use the same concepts that we have learned in last 10 lectures almost, from starting on the single linked list to then doubly linked list, then circular linked list. We have seen the many algorithms related to that. I don't think we need to revise it. Now, any doubt till now? Circular linked list, it is circular linked list. In last class, I also had discussed about the implementation of stack and queue using linked list. Yes or no? Am I audible?
Yes, sir.
Okay. So tell me, we have discussed about the stack and queue implementation of the linked list. Is it okay to you?
Yes, sir. किया था previous class में stack को
किया
भी
था
और queue को भी.
हाँ बिल्कुल. So वो clear है?
सर क्यू का एक बार वापस रिपीट कर देना सर, क्यू विद लिंक लिस्ट.
Okay, ठीक है. I will do it. No issue. So you need to speak now. When I am asking, तभी भी नहीं बोलते हैं आप लोग. Otherwise आपको अपने आप बोलना चाहिए. Sir, in last class we have discussed the things and please repeat that thing. And it means कि you are not studying at all. If you are studying, then you just have a problem with you. Or we almost have 40 classes. I think today is our 40 class. तो मुझे कभी भी ऐसा नहीं लगा कि
Yes, sir.
आपको आते आप
39
बोलेंगे, आप आते कभी ये बोलें कि सर in last class we have discussed this thing and this is a problem with us. Okay, now we are coming on to the next last topic of that linked list, that is according to your syllabus. I have seen the syllabus actually and deployment. And suppose मैं ये मिस भी कर जाता तो भी मुझे कोई बोलता नहीं कुछ. आप लोग वो भी नहीं देखते हो, syllabus भी नहीं देखते हो. I need to start the next unit and I have just recap the topics that I need to cover. So एक topic रह गया उसके अंदर, reverse operation of the linked list. That we need to do now. Okay, I am doing this. Linked list जबकि हमने पढ़ ली है, बहुत टाइम भी हो गया, 7 दिन हो गए पढ़े हुए, आप सिलेबस भी देखते नहीं है. So I request you all to go through the syllabus once today only, not of my subject, of all subjects. If some topics has been there which has not been covered, so you can ask the faculty member to cover it. Okay, because you have only 1 week now. So reverse operation of the linked list. So what do you mean by a reverse?
पीछे की तरफ जाना.
Accessing from the last node.
Suppose we have a linked list 1, 2, 3, 4, 5. So what is the output if you have been asked to print the reverse of your linked list?
5, 4, 3, 2, 1.
5, 4,
Yes,
3,
so
2,
we
1.
need to we need to reverse the linked list. Okay, so now tell me how it can be done. Any idea about that?
So we need to
Anybody
make
has?
a tail pointer.
सर नोड को
I am asking about a single linked list. Okay, so you just think upon what we can do for reversing a
Sir,
linked list. Logic.
स्टार्ट पॉइंटर है जो उसमें पीछे का एड्रेस जो सबसे लास्ट नोड है उसका एड्रेस आ जाएगा.
कैसे आ जाएगा?
Sir, with the help of stack, we can do it.
With the help of stack नहीं करना है हमें तो linked list को ही करना है. Linked list को reverse करना है बेटा. You need to perform the linked list, sorry, operation, reverse operation on the linked list. With the help of stack कैसे करेंगे हम बताइए? You can put all the elements in the stack. Good, you can think upon that, but if like you can take the elements one by one and you are putting them into the stack operation, and then you are popping the operation and you can put the result into the nodes. That is what you are saying.
Yes, sir.
It can be done. It can be done if we have been asked by using stack. That is very easy. It is always easy to reverse the elements using the stack because they said that this is a very familiar application of the stack actually. Okay. So now suppose the thing I have discussed is सबको समझ में आया क्या discuss किया मैंने अभी? How we can do the reverse of the linked list with the help of stack?
Yes, sir.
है ना? If we have been used to ask stack, that is then only we can do. You just start traversing from the linked list from the start, put first element, push into the stack, second element, push into the stack, and so on. When the last element comes, okay, again you need to start traversing of the linked list. From at the first node, you need to replace the topmost element of the stack, and so on. So in this way, you will be able to reverse the linked list. But in that case, you have lost your first linked list. That we have in that case also. So now suppose you are not able to use the stack, then how you can do it? Without any external help, you need to do it. How can we do it?
So we will traverse till the last node and print it, then second last, then
Yes sir, PTR वो जो ट्रैवर्सिंग है वो हमको लास्ट जो स्टार
अरे
पॉइंटर की तरफ करनी पड़ेगी।
एक को बोलने तो पहले, यदि कोई बोल रहा है, let him finish first. If someone has started, then everyone has like come into the ground and start fighting. I am giving you the chance. Yes, first जिसने बोला था वो बोले.
so it's like we can print in the reverse order by moving till the last node.
So it means first of all you are traversing till the last node.
Yes sir, and we print that, then will be last second node. It can be done in big O of n square, sir.
That is the second part. Now what you will do if you have reached the last node, then what you will do?
So I will print that value at the last node.
Print होगी. Okay, then
I will traverse to the last second node.
कैसे?
So with the help, means I will use either counter, or I can use means if I know the value, that the value I printed, then I will stop my value before that.
नहीं, how it is possible to access the previous node actually?
So if we are in loop, then we will use a count variable with count minus minus.
Oh, what you need to do if you want to access the address of a node? Suppose 1, 2, 3 are there. I am creating a node simultaneously. Okay, it is visible to you now?
Yes sir.
Okay, so as someone told us कि we need to traverse first of all. Suppose यहाँ पर आ गए हम लोग PTR पर, यहाँ हमारा PTR है. Okay, now what? You are able to print 3. That is okay, good. Now how you will print 2? What you need to do print that 2?
So we start from again starting.
Okay, so it will not n square. It will be n की power n.
N की power n. Yes sir.
क्योंकि you need to traverse n times.
Yes sir. Yes sir.
Because you need to traverse n times of the link.
Number of nodes.
Then this is not the good way actually. You cannot traverse like 1,000 times of the linked list.
Also we can means traverse in a simple way and copy the value in an array, and then we reverse the array.
No, you are not supposed to use any other data structures. I have already explained. Otherwise, it can be done with the stack already. We have done it. We have used stack. It is better to use stack instead of the array. तो इन स्टैक में क्या होगा? फर्स्ट एलिमेंट रीड किया, अंदर आया, सेकंड एलिमेंट रीड किया, यहाँ आ गया, थर्ड एलिमेंट रीड किया, यहाँ आ गया. एंड दैट यू नीड टू.
सर एक बात पूछनी थी,
इसी से रिलेटेड है ना बेटा? द क्वेश्चन
यस सर, इसी से रिलेटेड है.
पूछिए, फटाफट पूछिए.
तो सर हम प्रीवियस को नेक्स्ट क्यों कर रहे हैं, जबकि जो ट्रैवर्सिंग पॉइंटर है पीटीआर, उसको नेक्स्ट क्यों कर रहे हैं, पीटीआर नेक्स्ट? क्योंकि उसके वो तो पहले से और लास्ट नोड पर है ना, तो हमको उसको प्रीवियस नोड पर ले जाना है. तो पीटीआर प्रीवियस नहीं होना चाहिए.
मैंने कहाँ बोला कि पीटीआर लास्ट नोड पे है? we have taken that PTR to the last node. We have traversed starting from the first node, then we have moved to the last node. Now PTR at the last, ऐसा अजय ने बोला हमको. Okay, PTR as last now. अब previous तो इसमें है ही नहीं. क्या ये डबली लिंक लिस्ट है?
नहीं सर.
तो फिर previous कहाँ से आएगा?
नहीं सर, मैं वो यूं कह रहा हूँ कि हमको पॉइंटर को, जो ट्रैवर्सिंग पॉइंटर है, उसको पीछे ले जाना है, तभी तो हम रिवर्स कर पाएंगे सर.
तो लेके जाओ ना, वो तो हमें भी पता है बेटा. आप तो क्वेश्चन बता रहे हो, आंसर बता रहे हो आप.
सर क्वेश्चन ही बता रहा हूं.
If we have traversed the last node, then it's impossible for us to come back to the previous node. So in that case, we will be at the first node, and with the help of previous PTR next to next of data, इस ऐसे हम एक्सेस कर सकते हैं सर, जो लास्ट नोड का डेटा, देन पीटीआर नेक्स्ट का डेटा, एंड देन पीटीआर डेटा. इन दैट हम सर लास्ट एलिमेंट, सेकंड लास्ट एलिमेंट और उससे पहले एलिमेंट प्रिंट कर सकते हैं.
You are saying this because you are seeing only 3 nodes in that linked list. Now suppose there are 30 नोड्स ओनली मान लो, 30 नोड्स में भी आप कितनी बार नेक्स्ट लिखोगे आप?
Yeah, that will be so much.
मैंने तो 30 बोला है केवल, सपोज 30 के लिए तो कोई लिंक लिस्ट बनाएगा भी नहीं एक्चुअली. In generally linked list can be used for the very large amount of data. It cannot be possible to write like these many times of next. बहुत simple method है.
But we can swap the nodes with each other.
How you can swap now? Let us try to swap. 2 और 3 को swap करो. How you can swap it?
सॉर्टिंग तो
जब
करनी
हम
पड़ेगी.
इसमें लूप चला रहे होंगे सर, जब हम इसमें लूप चला रहे होंगे तो हम जब लूप सेकंड नोड पे होगा या सेकंड लास्ट नोड पे होगा तो हम उसका वैल्यू स्टोर कर लेंगे और उसके बाद वाली की भी स्टोर कर लेंगे और फिर हम उन दोनों को स्वैप कर सकते हैं.
But we will do like temp
Then-
equals to PTR next and PTR next equals to PTR next. So वो भी सर वैसे ही हो जाएगा अगर ज्यादा लिंक लिस्ट हो गई तो. If we try to swap, if you
Please
have
keep that thing in your mind कि you have a linked list of very large amount of data. All that what you are talking about, it is only feasible in the case of 2 or 3 linked list nodes. Now let us
We
come
can
to
use header node.
what is the like what how it can be helpful you.
So like you are saying that in that we can store a number of nodes on data.
Yes, then what? How you can use that thing?
So if we will store the data before, means all the data in header, then we can use only header to do that.
So in a header you are having the like data of every node.
Yeah, sir.
In header you can have the data of 1000 nodes. That is what you are saying.
Yes, sir.
How it is possible? Like how you are going to do it?
So with the means I can declare a means array or anything inside the data value multiple. Means is it possible like a linked list can hold an array and a pointer?
It can hold an array and a pointer.
Yes, sir.
So array भी हो गया तो array को क्या हम उसको केवल array की हेल्प से रिवर्स कर देंगे उसको.
Yes, sir. Like that.
Good. But my question is very clear. You need to you are not supposed to use any external data structure for that. You are only supposed to do with the help, but whatever you have been given with you. Now let me explain. Okay, that is easy. Now this operation can be done. First of all, you need to traverse through the last node. अब आप last node में what we have actually, we have the null value in the next part. Yes or no?
Yes, sir.
है ना? We all knows that we have a null values at that last node, next of that last node. So we can use this to point to the previous node. We can store the address of this with the help of, in that case, definitely we need to take 2 pointers, PTR1 and PTR2. So like suppose PTR2 is at the last node, so PTR2 next is now PTR. Can it be done?
So please repeat, sir.
Suppose this is PTR, P1, and suppose this is P2. Yeah, first of all, can we do this? P1 and P2. We can make a loop and we can traverse till the last node, and the situation will be like this: ki P1 is pointing to the second last node and P2 is pointing to the last node.
Yes, sir.
Can we done this? Then we can make the next pointer of P2, which is right now null. We are now making changing the value and updating it, and we are trying to put the address of P1 into that with the help of the statement P2 next, which is right now it is null. Null है ना वो last node, because P2 is the last node with
Yes, sir.
P1.
Yes.
Can we done this? Can we do this?
Yes, sir.
So now what happens कि this particular node next of last node is pointing to the
सर एक बार फिर से बताना सर.
P2 is the last node. उसका next pointer क्या है अभी?
P1.
Null है. Okay, and we are updating it. Now it will be pointing to the P1. हम उसको अपडेट करेंगे और हम उसमें P1 का एड्रेस स्टोर करेंगे एक्चुअली। सो अब हमारे पास लास्ट नोड में प्रीवियस नोड का एड्रेस है। सो क्या मैं इस डाटा को एक्सेस कर सकता हूं? है ना?
Yes, sir.
यस
अच्छा, आउटपुट क्या होना चाहिए? चलो मैं ये बताता हूं आपको एक बार। आउटपुट जो चाहिए वो मुझे ये चाहिए। इसका आप लास्ट वाले का आउटपुट देखो, लास्ट डायग्राम है वो देखिएगा। इसके अंदर सिंपल, you are seeing this first one, this is your input, this is your input, you are seeing this, and this is your output. Oh, sorry, just see what actually we want. Reversing means ki now last node becomes the first node and the first node becomes the last node. Is it clear what we want actually now? Yes or no?
Yes, sir.
Okay, so now, so first step we have done is we have made the null pointer of the last node to the pointing to the previous node. अब ये एड्रेस हो गया। अब आप P1 पर हैं। ओके, नाउ व्हाट यू कैन डू, now think upon again, you just start thinking again what you will do now.
Sir, P2 minus minus and P1 minus minus.
क्या ये कर सकते हैं हम लोग?
No, sir.
पॉइंटर्स पे कभी भी मैथमेटिकल ये वाला ऑपरेशन परफॉर्म नहीं होता है।
Yes, sir.
पॉइंटर्स पे, पॉइंटर्स को वी कैन नॉट डायरेक्टली प्लस प्लस।
No, sir. Sir, I'm saying कि हमें पीछे करना पड़ेगा इनको एक एक पोजीशन।
ओके ओके ओके, आई थॉट दैट कि
Yes,
यू
sir.
आर सेइंग पीटीआर
नहीं नहीं
माइनस।
सर, मैं ऑपरेशंस की बात नहीं करती थी।
हाउ यू विल डू इट?
Like, sir, if we can do like P1 to null.
P1 to
Null. No, sir, not possible.
I have initiated, now you need to think upon.
As we have stored the address of P2 next in P1, then we are going to store the address of P1 next to the previous node of P1.
That is what we need to do. Very good. Now we need to store. Now what we need to do is actually we need to make this next pointer to the previous node. How it can be done now? Expecting answers from the audience. 4-5 बच्चों के अलावा भी बहुत से लोग बैठे हैं। I just want everybody needs to speak or think upon. Nobody is going to have an answer.
So in this case, we need another pointer for storing the address of P1 next. As we have stored P2 next in P1, then P1 next in another pointer.
So how it is be possible?
But for then for the every previous node, we will need another pointer, and there will be a lot of pointers.
हाँ हाँ, तो वो नहीं करना है ना हमें। वो नहीं करना है हमें, तभी तो मैं बोल रहा हूँ आपसे। बताइए बताइए।
नहीं
Sir, I guess we will use P1 and P2.
P1 and P2 we have used, and how it can be used? We need to use P1 and P2 only. What we can do extra?
Sir, like again, we will start traversing till the last second node, means last previous node of P1. And we'll
Starting
update-
bar traversing is not like a good idea. That is the way that we can do. I am not denying it, but it is not a good idea actually. It could be the one way. No one else is there who can discuss it. There are 49 people for in the class actually. Garima, Harsh, no one is there. Chestha, Chirag, Utrancha, Anmol, if you want to speak anything, you can speak.
No, sir.
No, sir. Why? You are not getting it, what we are studying? Atishay,
Yes, sir.
answer me what I have asked. What was the question? For your convenience, I am showing the PPT. Nobody is going to answer it. Basic concept, you are getting it or not? Now let us again discuss it. Have we got the basic address? How we can do it? The thing that you have not answered is how we can move from the pointers to the previous one. But the logic is clear or not? What you need to do? अब क्या कैसे करना है वो आपको समझ में नहीं आ रहा है.
Yes, sir.
Except the last, like we need to start from the last node in this way. As we have first traversed the last node, we are updating the next pointer to the previous pointer. Okay. Now in this way we need to move till the first node comes, and first node will be the node which addresses is start. Okay, and we will make them the next pointer of that node as null, as you are seeing in this diagram. I have deliberately choose only the two nodes. Okay. So in this way, the first node is becoming the last node, and we are actually connecting to the last node till the first node. And that is what the reverse of the linked list is. Now finally, header और the start pointer actually जो है वो अपने पास last node पे होगा. उसको आपको temporary में hold करना पड़ेगा एक बार. Initially, at that point only, you need to store the P2 is equals to temporary, so that at the end you can change the start. Start will be temporary. Okay, that is what I
Sir,
have
please
discussed.
repeat.
I am saying ki initially what we need to do, we need to use one more pointer that will be temp actually, and we need to initiate temporary equals to pointer p2, because p2 is going to change now. Okay, p2 पूरा प्रोसेस में चेंज होने वाला है अभी. ये समझ में आ रहा है आपको या नहीं आ रहा है? And then when we like traverse all nodes and we have reached to the first node and उसका null करेंगे, उसका next pointer we will null, जैसे कि हमने इसमें किया है. Okay, this is the first node and we are making the last next of this node is null. So after that, what we need to do, we need to break this connection also. Now header will not point to this because this is the last node. So header will point to the first node. So in this case, header और start जो है वो क्या हो जाएगा? Temporary. यहाँ start is header actually. Okay, so it is temporary now. So temporary equals to हम, oh sorry, start is equals to हम temporary कर देंगे. So in this way, it will be in the reverse form.
Sir,
Yes.
सर सिर्फ P2 थोड़ी चेंज होगा, P1 भी तो चेंज होगा ना?
होगा. That is what I am asking from your side. I need that you will give the answer. मैंने ये तो बोला आपको, ये बीच वाला एक पॉइंट आप नहीं कर पा रहे हैं, आपको वो आंसर देना है. Rest all I have explained. And I want that the answer from your side only. आप लोग चाहे सर्च करें, चाहे कुछ भी करें. If you need time, then you can also ask me.
Sir, do we have to go through means? Sir, हमें P1 के previous node पे जाना है P1 की help से.
Definitely.
So, sir, can we use the same operation like we use from the last node to the P1 node?
Sorry.
सर जो हमने लास्ट से प्रीवियस नोड पे आने के लिए जो ऑपरेशन लगाया था P2 का नेक्स्ट इक्वल्स टू P1. So now we have to make P1 का next equals to the previous node of P1. How we are going to access that, sir?
हाँ, that is what the question is. इसी का आंसर चाहिए मेरे को आपसे. So I am expecting it from your side only, and you need to answer it only. अब आप चाहे आंसर दें ना दें, but you need. I will not give till you will not give me. So आप लोग ट्राई करो. Monday तक you have a time. Monday we have a lecture. In that lecture you need to give me the answer of this. Is it okay?
Okay, sir.
You need to search upon this. आपको सर्च करना पड़ेगा सबको, and then you will give me the answer. And now it is over. Linked list is over now. तो Q आपने बोला था लास्ट में Q डिस्कस कर लेना, तो I am going to discuss the Q now. Okay. So in this PPT we have a like traversing of circular linked list also. मैंने वो भी डाला है. It is very much similar to that. I'm not going to explain it. So traverse, how the queue will be looking like that, I am just going to discuss it within 5 minutes. So now suppose this is our queue. लाइनें अच्छे से बनती मुझसे, है ना, कोई बात नहीं. It is a queue. So this is our front. From front we can delete, and this is our rear. From rear we can insert. Suppose we want to implement that with the help of linked list. So what we will do?
So we will delete from the beginning.
We will delete from the beginning. Good. Now this is suppose linked list. Corresponding linked list it is. First node, second node, third node, last node, and so on.
And
Insertion at
the end.
Okay, this is your start. Now if you want to implement queue with this, so we need to for the insertion in a queue, what we need to do?
Insertion
Insert at
from
the
end.
end.
Insertion from the end, and deletion from the queue. What we can do is
Beginning.
From beginning.
So that two operations.
Delete from beginning.
So that two operations we need to perform only. Can we do it? Ajay, is it clear now?
In the beginning means front or rear?
In the beginning means front.
We are going to insert from front and delete from rear.
Yes. Now suppose also if it is a queue, so definitely this is your front and this is your rear now. So one more pointer we will have, that is the last node pointer. Temporary pointer की तरह हम लेके चलेंगे ये pointer. Last pointer जैसे हमने we have discussed that thing in circular linked list ना. कि last
Yes, sir.
pointer.
Tail pointer we can
Yes,
say.
sir.
So in that way we can use up another pointer in that is rear. So front and rear we can use. तो front पे deletion करना है and rear पे insertion करना है. That's it.
Sir,
Yes.
sir, please revise stack also using linked list.
No issue. Like now you can write the algorithm of this now for insertion at the beginning in the linked list and insertion at the end of the linked list, deletion at the first, deletion at the end. ये तो मुझे explain करने की जरूरत नहीं है ना.
Yes, right.
सर इनक्यू और डीक्यू ऑपरेशन में चेंज करना पड़ेगा, बाकी सब वही रहेगा
NQ और DQ ऑपरेशन
जो
ही होता
क्यू
है.
इम्प्लीमेंट.
Q में NQ और DQ ही होता है ना. तो अब देखो, सपोज दिस इज आवर स्टैक नाउ. तो स्टैक में वन इंसर्शन और डिलीशन कहाँ से होता है?
Top.
टॉप से होता है ना. दिस इज
Top
आवर
से.
टॉप नाउ. This is our top. Or if I want to insert it and if I want to implement it with the help of linked list, then what? Suppose this is again same linked list we are using. So this is my top now. The top pointer I need to use. So for insertion, what I need to do?
Insert at the beginning.
Insert at the beginning. And from deletion, what we need to do?
Delete also from beginning.
Deletion at the last.
Yes. So I should
इंसर्ट
say,
एट बिगिनिंग, delete.
I should say कि push operation is nothing but, बताइए क्या है push operation?
Insert at beginning.
Very good. Insert at beginning. That's it. And if I'm talking about the pop operation, what it is?
Delete from the beginning.
Delete from beginning. ये correspondingly algorithms हैं linked list stack की, if we are going to implement the stack using linked list. For pop, you need to write the code for insert at beginning, and for deletion at beginning, and for push, you need to write the code for insert at beginning. That is what you need to do only. Same in the case of Q, for the front, for the deletion and the insertion, we can write the algorithm. Is it okay now?
Okay, sir.
Okay, sir.
So that is okay for today's lecture, and I am going to take the attendance.